Hello and welcome to your 5th tutorial in programming games using LWJGL. So we left off here with this. We took away all the translations and now we're going to take away more. I'm going to even get rid of this colour because we're going to be focusing on textures today. So the first thing we're going to want to do is actually enable textures. So we're going to go to the init OpenGL function and we're going to call gl11.gl enable gl11.gl underscore text texture underscore 2D. This is going to allow us to load in a 2-dimensional texture. Don't worry about 3-dimensional textures because I don't understand them either. Okay, so the way a texture works in OpenGL is that we actually have an integer to store a reference to it, so that we can say, look, this is where the texture is, use it. Basically, it doesn't actually have a texture variable as other graphics libraries would do. So we're going to create a private integer and just call it texture. This is only going to be temporary for now. And we're going to create a... Okay, let's create a new method. Public void init prog, and this is going to be it for initializing the program, any variables that we need to set up. So let's start by actually calling this dot init program in the bottom there. We're going to do texture. It's going to be equal to this dot load texture. Let's do image.png. Okay, so let's create this method. Okay, so by default it's going to return 0. We don't want that. So this is this is going to return an integer, and this integer is going to be basically the reference to our texture. So we're going to start by creating a result that we want to output, and we're going to call this texture. We then want to create a buffered image. Now this isn't actually LWJGL, this is default Java. If you ever work with like pixels and stuff, you'll know what this is, hopefully. We're going to create a try-catch. Actually no, we won't create that because Eclipse will do that for us. So we're going to say image is going to be equal to image IO. That is the phone. Hold on 1 second. Okay, sorry about that. That was the phone. That's my dad calling. Right. So we're going to want to do image io.read, and we're going to want to take this string variable, but we need to get the resource as a stream because otherwise we can't load it in. And we need to import Bufferedimage, and yeah, we need to transfer the try and catch. So in this e.print trace above that, we're actually going to put return 0, so that we don't actually return an image. If we fail to actually load the image in, we're just going to return no image at all. And yeah, that should be good. So now we're going to want to take some data from this image. We're going to want to take the width. Width is going to be equal to image.getWidth. The height is going to be to the image.getHeight. I will warn you, in a second I'm going to go into a big deep explanation using paint, so prepare yourself. Then going to want to take the pixels. Now this integer array is going to store some stuff that I'm going to go into in a second, once we just set this up. So what we're basically going to say here is how much of the image data we want to actually scan to get the RGB values for. We want to do all of it, so we're starting at 0 and ending at the width and the height. And we're going to put null there because it's actually going to return the RGB array. We don't need to pass an integer array because it's going to return that and assign it to the pixels variable. We don't want any offset, and the scan size is just going to be the width. Okay. So let's get into hexadecimal colors. Okay, let's get my rubber. Oh, that's rubbish. Let's just create a new one. Right. So let's make the size of this thing a bit bigger. Right. So if you've done binary before, you may know that there's 8 bits in a byte. So we have like 1, 0, 0. There's 8 of those in one byte. 8 ones and zeros in a byte. And the way that hexadecimal works is you have, say we've got 1100. One hexadecimal integer represents 4 binary. So this particular number would be 1, 2, 4, 8. This would be 9, A, B. This would be C. The reason being is hexadecimal is actually a base 16 counting system. It goes 0 to 9, then to A, B, C, D, E, F. So that's why that happens. And if we string two like decimal numbers together, like so we just get that to return CC. Those of you who know about your computer graphics will know that you represent color data from 0 to 255, and you'll notice, if you're good at binary as well, that 2 hexadecimal digits or 8 binary digits or a byte actually is a maximum number of 255. So the way it works is we represent each color value with 2 hexadecimal digits. So if I wanted a really, really strong red, 255 red, no blue, no green, what my hexadecimal number be F, because it goes red, then green, then blue. No green, and no blue. And equally, if I wanted green, I'd put 00 in the red section, and FF in the green. So I'll just highlight these, make this green, that's a really bad G, and blue. Okay, so that's basically the hexadecimal representation of colours, and I'm going to show you in code now how we can represent hexadecimal in code, because this is very important to how we do it. So I'm just going to create a quick variable. We're not actually going to use it. The way we represent hexadecimal in Java is we just put a 0x before it. So to create that, we're going to do ff0000, and Java is actually going to see that as a proper number. Now, another thing to understand is if we were to print that out as an actual number, it would be ridiculously huge, because obviously red is a lot bigger than red is a lot higher up the hexadecimal than the blue and the green. So the way we actually get the individual values from that is we use a technique called bit shifting. So say if I have a 1, a 0, a 0, and a 0, and I decide to bit shift this, I don't know, bit shift it right twice, I'm actually going to be left with 0, 0, 1, 0, because I've moved this 1 2 bits along. So let's just create another new one, and we're going to go back to this hexadecimal thing. So let's go back to this whole red thing. F 0, 0, 0, 0. Since this red number is going to be ridiculously huge, to actually get the red value between 0 and 255, what I need to do is I need to bit shift this 16. If you remember that like each hexadecimal digit represents 4, we've got 1, 4, 8, 12, 16. So we're going to need to bit shift that over 16 to take our red value from it. And I think that's basically it. I hope that makes sense. If there's something you don't get, please again post in the comments. So we're going to need to create a buffer of bytes, and the buffer of bytes is basically going to store all the image data. So bufferutils.create byte buffer, and the size is very important, because what it does is it stores the number of pixels we have times 3, because it stores the red in each byte. It's going to store the red value, the green value, and then the blue. no, sorry, it's going to store a byte for red, a byte for green, byte for blue. So it needs to be, so how many pixels are going to be in the image, aka width times height, and then times by 3, because we need to store the R, G, and B values for that. I hope that makes sense. And then we're going to just tell OpenGL, nice bit of easy OpenGL, just if you were getting a little bit confused. And we're going to just tell OpenGL we want the texture to be a generated texture. Now we're going to create a for loop, and this for loop is going to increment through all of these pixels that we got earlier on. I'm going to do I++. Okay, let's do Control-Shift-F, just format this all. Right, so now we want to assign to the byte buffer the red, green, and blue values of the current pixel we're on. So we're going to create a byte for red, and hopefully you should all understand this now from my explanation. It was probably quite bad, but yeah. So we're going to get the pixels at the current I position, and you know, this kind of like bit shifting that I showed you, we represent that in Java with two like greater than signs. If we wanted to bit shift it the other way, we'd use smaller than signs. Okay, so we're bit shifting that over 16, and then we're going to use an AND function called naught. We're going to do naught times FF. And what an AND function basically does is it's going to say, so say if I have two values here, two binary values, and if I AND these together, I'm only going to get 1, 0, 0, 0, because what it does is it returns the binary value where both binary digits are 1, and it works likewise with hexadecimal. So it doesn't matter so much with red, but I want to basically only get the red function. Now, because I've bit shifted this over 16, I'm only going to get a number between, I only want the number between 0 and 255 that represents red. So I'm going to AND 0 times FF to make sure this number is the red between 0 and 255. This is probably making no sense at all, but I tried. Did we just do the same with a byte called blue? We've got a duplicate variable. Do we? Yes, we do. Let's just make this RR and BB. Blue is likewise, except we only right shift at 8 because that's represented by the second set of hexadecimal digits. And oh, hang on, that should be blue, not green. Sorry. No, that should be green, not blue. And then this one we don't actually bit shift at all because it's actually there already. The AND 0 times FF is very important for green and blue. You're not going to get good results. Red is not so important if your image doesn't have transparency, but it's fine anyway. So now we want to send these red, green, and blue values. So we're going to want to put b.put rr, b.put gg, guys, gg, and blue. And that's going to assign the red, green, and blue values of that particular pixel. And then it's going to loop to the next pixel, and it's going to do that. Okay, we've got through the difficult bits. This is going to be a long tutorial. We're then going to want to call b.flip. This is going to just basically compile the buffer now. The advantage to a buffer is it doesn't take up loads and loads of memory data. I'm not entirely sure. I haven't really worked with a lot of buffers. But I think the flip variable basically compiles the buffer so that it's no longer open and we're not editing data in it anymore. So it means that we uses up less memory. So we're going to want to bind this texture, because what we want to do is set up some stuff for this texture. So we're going to bind the texture so that we're setting up items for this particular texture basically. And then equally below that we're going to unbind the texture by just putting 0 instead of our texture integer. So now we're going to call a gl11.gl text parameter I. Now do you remember what I said about this I thing? That represents integer, so this is taking 3 integers. So we want to say this is a 2D texture. The parameter name we want to focus on is the min filter. That should be GL underscore texture underscore min underscore filter and GL11 dot GL underscore nearest. Now there's two different ones you could have put there, but I'll tell you about them later. Geo texture min filter is not available, cannot be resolved. Why couldn't you get that? Oh, it's because I keep missing off the T's of texture. Right, so basically the min filter is when it's on a very small area, and the one we're about to make is not the max filter, but for some reason it's called the mag filter. I think that's for magnification. I don't know why. OpenGL is a bit stupid, really. And then finally, we're going to want to actually assign the pixel data that we collected up here. So we're going to want to call g11.gl text image 2D. Right, so we're going to want to start off again by saying this is a 2D texture. Yep. And then we're going to want the level can be 0. The internal format is going to be gl11.gl underscore RGB. It's interesting to note you can also have like GRB or BGR if you wanted to. If you had like a weird image editing program and you wanted to play about with it, you can do that. So we're going to want to simply pass the width and the height of the image we just loaded. Border needs to be 0. Border doesn't do what you think it would, but we're just going to leave it at 0 for now. And again, for some reason it wants us to put RGB again. Oh, not that. GL underscore RGB. And then for the type, it's going to be a GL11.gl underscore unsigned byte, because we're actually using a byte buffer. You could use an integer buffer and put unsigned int, but since our values are only between 0 and 255, you need bytes. And then lastly, we're going to pass this byte buffer in, and there we go. Phew. Oh, and last but not least, let's return the texture. So, congratulations, you made it. We've actually got our texture loader set up here. I hope my explanations made sense. We now need to just finish this off by putting this texture on our... Well, first let's create the texture. I believe I've already got one here, yep. This is a simple 8x8 little texture. And I'm going to put this in my directory where I have this. We're going to actually create a new folder in your project, call it res for resources, and save it as an image.png. And click OK. Right, and now we're just going to refresh this. No, it didn't come up. Hang on, let's just go back to here. I definitely saved it there. This is odd. Doesn't seem to want to. Oh, there we go. Now the res folder has appeared. So we're going to need to want to right click on. We're going to want to go back to the build path that we used earlier. We're going to this time add a class folder, and we're going to click on res. So we're actually going to use all the images we store in res and other things. So now if we run this, hopefully it should load the image. Yep, it has thrown an error, so I think we've loaded the image correctly. So we're going to do gl11.gl bind texture gl11.gl underscore texture underscore 2D and this dot texture. So we're binding that texture to it basically, and we don't need to do this, but afterwards I'm just going to bind no texture so that we get rid of that, and these should be indented. This code is it looks horrible to look at. I'm gonna like put some line spacing so it makes more sense. We then need to assign a texture coordinate. So this is the coordinate of our texture that that particular vertex is going to account for. So we're going to create text coordinates above all of these, and the first one is going to be 0, 0, and then 1 0. It's a value between 1 0 and 1. If you put higher than 1, you're actually going to get a tiling effect. Actually, no, you may not get a tiling effect, but we need to change that in our texture loader. If we run this, there we go. Wow, I'm amazed that worked first time. We've loaded in a basic image today, and if you want, you can change the image and play with it. One thing I'm just going to show you, this Geo Nearest function. I'm not going to go into too much explanation of what this does in paint.net, because I feel I've done too much of that. But Geo Nearest is what you want to use if you've got pixely textures. I'll show you what happens if I do... Ooh, I've even forgotten what it is. I think it's GL Linear. Yeah. If we assign a linear type to it, it's going to be all fuzzy. So if you want to have, if you've got high res images, linear is what you want to go for, because it's going to blend all your pixels together. But if you're using pixely, you want to use nearest. And of course, if you're not sure which one you want to use and you want to change it, you could always pass them in as an actual parameter to the function and change it in here. That's one of these awesome things, you know. If you want to load in a couple of different types of textures, you can just add some stuff to the function here, you know. Play about with it. One thing that's always fun to do is like maybe swap blue and red around here, and you'll see that it comes out orange because it doesn't read it correctly. But it's quite fun to just play about with things. Yeah. So I hope that made sense. If it doesn't, don't worry too much. Hopefully you should pick it up. And yeah. Thank you for watching, and I guess I'll see you next time.